Right, good afternoon. I'm sat here with Brian Roeten from CopSonic, and today we're going to be discussing the benefits of ultrasonic technology and the impacts that might have on the mining industry. So, Brian, thanks for sitting down and talking with me. The mining industry has a number of challenges, right, around safety and security. There's a lot of things that go on mines. We can deal with some very valuable resources in terms of, diamonds and gold, things that are very easy to pop in your pocket and walk off. Likewise, there's a lot of equipment, right, that's on a site, and there's a lot of assets to be handled, and there's a lot of moving parts. So mines are very complicated areas, and they have quite difficult supply chains. So I guess there's a lot for us to talk about here. So to begin with, would you mind introducing yourself to the Axora audience, and then we can start the discussion.
Okay, well, thank you for getting me on board. So as for myself, as you said, I'm Brian Roeten. I'm the CEO of CopSonic. I've been in charge of everything related to business development, the discovery of the new use cases on the field, and also the partnerships, strategic partnerships. Over the past 10 years, we started in 2013, and I'm delighted to be on board with you.
Excellent. So let's start at the easiest point for the miners among the audience. What is ultrasonic technology?
Well, if you want to talk about ultrasonic technology, you need to put it in a framework. So we are living in a hyper-connected world where there are many different technologies being used for communication. These are being used to engage customers on their smartphones. Either they are Bluetooth, NFC, QR codes, ultra wideband. Well, probably you know a couple of them. And all these technologies still do not fulfill all user expectations. To drive adoption, solutions should be as universal, secure, and seamless as possible. And that is why at CopSonic we have decided to create a new near-field communication technology that allows electronic devices to exchange data between speakers and microphones just by using acoustic waves, ultrasounds, and sounds. So CopSonic offers this technology through a software development kit and a white label application set, which allows the integration of these ultrasounds as a communication channel inside existing environments. It is a complement or alternative to these other technologies that I just mentioned. It is a patented solution, which enables basically the exchange of any kind of small package of data between electronic devices with speakers and microphones, encrypted or not, in online and offline mode.
Okay, and could you give us maybe one or two examples of how ultrasonic technology is currently used in some other industries so that people get an understanding of the sort of base that it could be used for?
Well, the technology is aiming, as a matter of fact, three main activity sectors. To brass it up, the digital security one with mobile payment currently, online payments as well, authentication and ID management on vocal assistance, strong authentication, everything related a bit to the security aspect. Then there's smart detection, using it to detect people in specific places. So we do 3D secure, geofencing, second screen experience, smart building. And then there is IoT connectivity, where we are using it for IoT interaction, connecting devices together, access control, remote control, changing settings on devices. So the CopSonic technology is a communication channel, and as such, it is currently being used for numerous use cases within different industries. Among the first industries that have decided to integrate the technology, there is a public transport industry in France, the RATP, who was using it for warning pedestrians for incoming vehicles, for instance. Other industries like the financial industry is using it for payment and authentication on vocal assistance or payment between peer-to-peer devices. So basically, you can do anything with it. We're now even exploring the use of this technology inside TV and radio to wake up elements on TV screens or smartphones at home.
Okay, so it's got a pretty broad use case, right? And I can see a lot of those elements you've talked about being applicable in mining, whether that be ensuring people, the right people can access, say, a gold room or a safe room, to confirming that a person has the right qualifications before they can start a vehicle, and just things like tag in, tag out, and other kind of maintenance and type procedures when going in and out of a pit. So I guess there are a few areas we can go at. So to start with, I guess, let's start on some basic ones. So how could the technology, I guess, talk us through how it would be used in terms of prevention of theft or equipment handling or asset management? What would a use case look like and how would it be implemented?
So basically, theft is pretty much related to using the technology as an identity confirmation or authentication process. The idea really is to use the ultrasounds to carry the confirmed identity of the employee or the person visiting the pit, and from there on, his smartphone could carry this confirmed identity towards the strategic places, the door locks, the entrance, the gates, and so basically the integration will depend pretty much on the environment and the structure, the hardware structure that already exists, as to limit the efforts and investments on the side of the customer. But the idea really is to have this confirmed identity modulated inside the acoustic wave. Let's consider the acoustic wave as an envelope, and then this identity is sent towards the gate, for instance, and there the identity is taken out of this envelope to be confirmed and validated, and then it opens just simply as that. And from there on, you know who entered, at what time, and where he went, if he went in or out.
And of those use cases, right? Let's take that. That's a great example. Sort of how easy is it, and how versatile is the technology compared to what we have today?
So the speed pretty much depends as well on the quantity of data that you're going to transmit. So in many scenarios we are driving back the authentication experience to a couple of seconds only. So the process of the authentication, the transmission of the identity, takes between 2 or 3 seconds, and then the of course it depends on the speed of the system and the capacity of the system to validate this identity and to give the green light of entrance. But the entire experience is brought back to 5 seconds maximum. Where I see also a very positive point with regard to identity management is that you get rid of for instance, the physical cards. The physical identity cards are not always easy to manage. You need to encode them, to hand them out, to hand them over, collect them again after the visit. So it makes it much more digital. It is digitizing this process. So there is, of course, the experience at the gate for the employee, which is much better, but also the experience of the people handling this identity behind it, the ones who are managing it on a daily basis.
Okay, and sort of as what would a deployment look like? So say I wanted to use this, as in a vehicle, right? And in the same way a door lock works, so it would confirm the identity. How simple is a deployment for a mining operator?
So it all depends on the place where you're going to deploy it. So what we usually do is that we sit together and we analyze the environment in which you're going to deploy it. We check if there is already the necessary components on both ends, on the car end, for instance, or the truck end, and on the employee end. On the employee end, we often end up by using either a smartphone or by using a wearable. And in the car, we need to check if there is already the capacity of handling the speakers and the microphones, or if we need to add a specific IoT device for such process. So and then based on that, what we deliver is, of course, first of all, the software development kit, the SDK, which is going to enable to integrate this communication channel inside the professional software, which is going to be used. And when it is necessary, we can help setting up the necessary IoT elements that will be plugged inside the environment to give them the capacity and the intelligence to understand the ultrasounds as a switch between the for instance, the starting of the engine and the normal process.
Okay, yeah, I mean that's very interesting, I guess, in terms of the difference between a physical key of the past and a new way to manage, to make sure the person who's actually starting the vehicle has all their permits and they've done all the training required to start the vehicle, and nobody can just get in and turn the key and drive. So we've talked about the basics of the technology, what it does today. I guess, could you tell me a little bit about where ultrasound technology is going in the future and the sort of developments we can expect to see?
Well, the technology itself is, as I said earlier, a real communication channel. So basically, it can be used for many things, as long as there is a speaker or a microphone. And even when they're not there, we can bring them into the ecosystem. At CopSonic, we have always aimed to develop this software as a communication channel. It's a very horizontal thing, so we can deploy it as easily in the mining industry as we do it for the banking industry or the army or the retail industry. The kind of data that you transmit doesn't matter. It's more the quantity. And one of the biggest limits nowadays is often the quantity of data. But if you look more closely at it, in most cases, you do not need that much information to be transmitted. It's in most cases, 80% of the cases, it's small, very small packages of data that need to be transmitted. And there we are very strong on it. We recently broke the world record with regard to data transmission, achieving 10 kilobytes per second in burst mode between two devices in close range. So there are many opportunities that can be answered with such a solution. So the idea really is to drive the existing technology with something like 15 different algorithms that we have, which allows us to adapt it to different environments, to the noise of the environment, to the distance of interaction that we want to achieve, to the security of the signal that we need, because when you're dealing with an identity, it's not exactly the same thing as when you're distributing a loyalty coupon. And also, with the help of our research and development team, we are more than capable of taking this even further, just like we did with the RATP in France, and to solve specific issues of the environment, such as Doppler effects or very loud environments. These kind of things we can handle, and thanks to our R&D department.
Yeah, and it's really interesting, right? Because the mining industry is certainly one of those industries where there are so many use cases that could potentially be of interest, from things like emergency warning, where you broadcast something and everyone's phone picks it up, through speakers that they might not even necessarily be able to hear, through to turning equipment on and off, right? There are a lot of places where Wi-Fi or other types of communication technologies aren't necessarily applicable, right? Whether that be underground, because rock is hard to propagate, but sound may propagate better, or it's just long, big areas, or there might perhaps just be the fact that there isn't much infrastructure in the location. So it's got a lot of interesting use cases, which I today probably can't think of, right? There will be many undefined use cases that someone will think of that this kind of technology would apply to. So can you, I guess, give some other examples within sort of heavy industries of solutions that are being used?
Yeah, well, over the past months, we have had a couple of very interesting interactions with the heavy industry, with initial focuses relying on security, based on access control topics mainly. The idea really is to use it to manage and track the access of employees in the manufacturing plants. And at the same time, it is also very much related to the safety, the capacity of detecting these people in specific places, and putting the machines, for instance, in safety mode when necessary. With respect to this second use case, the different applications that are imagined are going in various directions. It can be checking the progress of guards during their surveillance rounds to make sure that everything is going all right. In other cases, it was related to checking the presence of an operator at the control station and putting it in safe mode, as I said, when he's not any longer detected at his control panel. But it also sometimes it is checking the presence of an employee in a restricted area and automatically switching his devices to airplane mode to avoid electromagnetic interferences with the infrastructure, or identifying employees in specific areas to give them access to hidden control systems because they are entitled to use them. This is really, for instance, for machines which are more and more hiding these controls. And then there is also, in another area, the identification of employees for maintenance contracts. That is to say, we track the intervention of the maintenance operator in front of the machine, and we combine it to the blockchain to record this as an event. So there are many features that can be empowered by the ultrasounds, either as a standalone or in hybrid mode with other technologies.
Yeah, and you know, the more you talk about it, right, the more you can think beyond the initial use cases. I think of, you know, working out who's allowed in what and who can start what vehicles, right? There's definitely some interesting capabilities there around things, even as much as blasting, right, to make sure that when people are near the explosives, their phones are turned off. I mean, that is a simple, straightforward use case that any mining operator would understand. And I think as we tease into this in the future, there are going to be a lot more different use cases that sort of come out where people say, oh yeah, actually that's really interesting, right? The one you talked about, contractors, people who are working on sites which are full of contractors, you know, and being able to bill for the hours they're doing, whether that's being in front of the drill or being in front of the truck changing parts. So I think there are many use cases that, you know, you and I today haven't thought of, but somebody out there has a challenge for that ultrasonic technology probably meets the needs of. So I think going forward, you know, we find this really interesting, and I hope everybody out there who's listening to this will see, and maybe someone will spark on an interesting use case and come forward to talk to you. I guess the big question for CopSonic is, you know, are you happy to work with people who come forward with new challenges, and how would that look, and how would you feel about, you know, going to a site somewhere in Africa to deal with a challenge, or down in Chile or Russia to come up when somebody says, oh, I've got a problem with a smelter and I think ultrasonic technology is the thing I need to solve my issue?
Well, definitely that makes sense. I must admit, of course, that CopSonic is relatively new in the area of mining industry, but that is exactly the reason why we're now in collaboration with you at Axora, because you're bringing us the expertise in this area, as a matter of fact, and you're capable of getting us in touch with the adequate people, those who are interested and have real needs. And most important, you're the ones who will point us on the reality of the field. And together we have we have already identified through this discussion a couple of interesting use cases. But I'm convinced that beyond this, we know that with the help of our research team, when necessary, we can go much further and challenge all these specific needs. And we're more than prepared to come to visit and to come locally to address all these problems with you.
All right, brilliant. Well, Brian, thank you for your time. It's been a pleasure as always. Take care, and, you know, we'll speak again soon.